Hi,
I'm
sir.
just going to set up I'm going just to set up a timer. So I will stop you when you're ready. Right,
Okay.
go.
So I can start now, sir.
Yeah.
Hi, sir. Hi, everyone. My name is Linda Mlotra. I designed an ESP32 GPS tracker with OLED display. So basically, I looked at the situation that South Africa is facing, which is vehicle theft. So we need most vehicle drivers need like a low-cost GPS tracker because most GPS companies they're quite expensive. So I created something that is cost efficient. So as you can see here, it basically receives signal from the satellite. I used the technologies that I used. It was a Neo 6M, U-Blox Neo 6M GPS tracker. I used an ESP32 and I used an OLED display. So the process that it takes is it receives, the GPS signal receives the signal from the satellite. So the LED will indicate that it sees the satellite. So what it does from there, it encodes the data in MEA format. Then from there, from the format, the ESP32 decodes that format. As you can see here, it displays the GPS coordinates. And what I like about this, I designed it in such a way that it does not receive anything. As you can see, it doesn't see any satellites. The lost information that it received, it stays stored there. And the IoT platform, because we're using IoT in the world we live in. So the IoT platform that I used was Blink. I configured Blink in a way that it will actually pinpoint where you are in real time. Even if the Wi-Fi is off, it can still pinpoint where you are before. So it stores that information there. So that's basically my project. And the challenges that I had while making this project was, my first one that was important was receiving satellite signals, because without satellite signals, nothing happens. So I had to be in an open area or close to a window or anything to receive those signals. Secondly, what I had a challenge about was the interfacing between the Arduino and my ESP32. It was quite challenging just to add the libraries in order for it to correspond with what I want as a whole. But in all essence, everything went smoothly. There were challenges here and there, but everything worked out. As you can see currently, these are coordinates that dictate that I'm here in S317. And as you can see here, the pinpoint location in Blink, in the Blink app. So yes, so this is my.
Okay, so what was your biggest challenge?
My biggest challenge was the receiving signals.
Okay.
It was, especially when I was doing it at home, I had to maneuver around the yard. It was challenging, and you can't work outside when there's bad weather condition as well. So that was the challenge I had.
So the satellite tracking is not that good.
The satellite tracking,
Yeah.
it is good, but
What is this, your antenna?
No, that's
yeah, that's the
GPS.
antenna.
That's the GPS.
So this is the antenna of the GPS. It's the antenna of the GPS.
Yeah.
So initially I wanted to use the M8Q Neo U-Blox, but it was so rare to find, and they need to import it from Europe. So I opted to go with something that's similar and will do the same process. So I got this Neo 6M because the similarities are not that far off. It can still function properly and do the work that I require it to do. And you can also expand it. As you can see now, it receives signals, so the blinking goes on, so it can see the satellites that it can see.
Okay, can you move your unit so we can change the...
You gaan het nie regtig so bietjie sien.
Yeah, no, otherwise you just program that thing. I don't trust him.
I know, sir, as you move, it changes, but I have to move
What a distance.
quite a distance. Because in the morning when I was...
The aim of this is to
It's to track.
I did cost effective of cost.
Low cost GPS tracker.
GPS tracker.
A low cost
okay,
tracker.
and that is for if somebody wants to steal your car or something like that.
Anything that you find valuable, but I took
Okay.
something that's like a high risk in South Africa.
Power source?
The power source, I use a power bank, but you can use a lithium battery as well. You can expand it, but I chose a power bank because
Okay.
a lithium battery, you have to change it, which will
How will it react to jamming?
react to jamming.
Yeah.
When it jams, the thing I like, it still stores the last information that you had.
Okay.
Right, because obviously there will be times you won't see any signals. There will be time where there's no Wi-Fi signal.
Yeah.
But the last location that it
So if
sees,
somebody wants to steal it, if you put
It sees
this on
it,
something variable and
changes.
somebody wants to steal it, jam it,
Yeah.
and move away, then you only have the way it was.
yeah, in a way. But
No, it's not
but
in
you-
a way, it is definitely so.
But you can expand it because that's one of the things that you can work on.
Because I know they use jamming
They
all the
jam,
way.
they jam all the way, yeah. But you can work on that, and just if you want to expand the project and make it in such a way that you prevent the jamming from happening, it's something that can be done in the future.
Okay.
Yeah.
So this is only reactive.
And in what way?
In other words, you're not picking up any signal from your vehicle that it's been broken into. So this is only you get to a parking lot, you see your vehicle is gone,
Yeah.
and then you'll go and have a look, which means it's reactive.
That's
It
reactive,
could have
yeah.
happened half an hour ago or
Yeah,
even longer,
that's one of
depending
the-
on how long you've been in the mall.
Yeah, that's one of the disadvantages that it
Okay.
has. But you can expand on
It would have
that.
been nice if you put it in a nice little box. or so, eh?
With that one, sir, I took that into consideration, but it's dependent where you want to use it. Exactly. So depending on where you want to put it, you have to cater for that space you want to put it in. I can't put it here, then you're going to put it in something that's like smaller and this won't fit. So whichever requirement, the enclosure can cater for it.
I'm not going to buy that one, but okay, I'll let it go.
The other thing that I would change on your layout was that this unit sit like this. So then you can make your board a little bit smaller as well.
Oh, okay.
Especially for putting it in some vehicle. or
Yeah,
whatever
yeah,
the
yeah.
case may be.
Yeah.
Okay, good.
All right.
Thank you very much. Good. Well done.
Thank you.
You can stop. Let me just get my stopwatch going. Right, start. Okay, tell us what's happened.
Okay. Hi everyone. So basically this is a ESP32 smart and safe watering system.
Take off your mask, I can't hear.
Sorry. Yeah, it's as I was saying, ESP32 smart and safe watering systems. So basically what I do to irrigate my two fields, I sense the humidity in the soil. From there, it's connected straight to my pump. When the humidity goes down, it activates the pump and it will irrigate either field. So if it's this one, the servo motor will stay on this one. If it's on this other one, it will turn and irrigate that one. And if my tank runs out of water, nothing will happen. So basically that's the project. And still I can request my values using Telegram. So it will give me the state of everything, the pump, the soil moisture, and the
Okay, so demo.
level. Yeah. So basically I've got two screens. When I'm going on the other screens, it's gonna see. It's where you can see all the measurements. So if I take this one out, it will activate the relay and it will irrigate this one. If it reaches the value, so it's gonna stop this one. This one, it's gonna go to this one. So when it reaches the value that I set to stop, then you got it 600.
Yes, so it doesn't sense on that.
It sense.
Yeah,
Shut on.
You just see it stops pumping before you put the sensor back.
Oh, so when I remove, so it's gonna check. And just set it. So when I remove the sensor, and the other part is on Telegram, and give me the readings. So I go on my phone, start. It will send me black welcome to answer all those things. To request the reading, I should send that comments. So I send these comments. I give 36%. Oh, you can please.
Just a pity you're drowning in plants now.
It's rice.
Sorry?
It's rice.
Nah, I was like in
No,
grass.
the rice takes a lot of water, so it's not
Oh,
even
rice.
rice.
Oh. Yes, basically that's it.
Okay. Right.
It's a pity your cabling is not neat, but the rest of the project is working okay.
Good.
Thank you.
Thanks.
All right. The one thing that you did not discuss is what was your challenges?
Oh yeah. First of all, I had a problem with the screen because it was getting disturbance when everything was working at once. The servo motor, the pump, and yeah. So when they are working at once, I was having the problem with the screen. So basically, that was the big challenge. I managed to fix it by using two different sources of power. One powering the LCD and the whole board, and the other network of power running the pump and the relay.
Okay. And then, okay, how did this play a role?
Sorry?
How did that your humidity play a role? Where did you measure that? That you didn't demonstrate that.
Oh yeah, this one is the environment,
Okay.
temperature and humidity around the field.
Oh,
You can
okay.
see but for the soil moisture, it's close to
Okay.
soil moisture one.
So that would automate. So that is the automation.
Yes.
And okay, you did that now manual. Okay. All right. Okay.
And
Good.
the tank is
Right.
level. Yeah.
What area are you looking at here in practice?
My garden. A garden, home garden.
A home garden.
Yeah.
With the automated sprinkler system.
Yeah.
Okay. So but how would you use your? So that was only for the demo.
Yeah. Because I had to switch between.
So you can have multi-stage.
Yeah, if I've got a lot of them, yeah, that I used to in case.
Then quickly on this particular, how accurate was this?
Sorry?
How accurate was this?
This one, it has a range. When you, let's say from the data sheet, they say it from 0 to 600 analog values that you're reading. So for me, I made it to be from 0 to 900, so that I have a bigger range. And I was calibrating it like half, it's already at 600, that the maximum values to stop the irrigation. So if it gets to 600, it's gonna stop. So the whole sensor, it's 900.
Okay.
So from 0 to 900.
But was it accurate enough?
Yes, yes.
Okay. Usually because that's not a very accurate type of sensor. We've experienced that. Even this is not very accurate. You get much more accurate
I
sensors.
think for irrigation purposes you don't need that accuracy.
No. Okay.
It's half full.
All right, good. Thank you. Keep my timer set up. All right, you have 5 minutes. So that is what you have done.
Can we start?
Right?
Because I haven't started.
Okay, I'm ready to go.
Okay, cool. Hi everyone. My name is Lukosha Deni, and I'm actually working on a hydroponic system. A hydroponic system is a system where we do not use, it's a planting system where we don't use the soil to grow the plants, but instead we use nutrients mixed inside the water, and that will be watering the roots. But unfortunately I do not have it here. I don't have the plants to demonstrate that.
Why not?
Because it requires lots of things, like nutrients, for instance. So in my case, as a problem, I identified that traditional farmers have a problem to acquire process variables values, such as temperatures, humidity, for simple watering. So as a solution to that, I worked on a system whereby it detects the humidity. I set the humidity to be every time the humidity drops below the value of 60, it should trigger the pump with the aid of a relay module, and also the lights I'm using. As the technology, I use the DHT22. It's a digital humidity and temperature sensor for detecting and measuring the humidity levels. This is an LDR, light dependent resistor. It also detects and measures the light levels, and it's in interconnection with the AC light bulb. And this is a submersible pump that allows me to water my plant. And to that, this allows the farmer to remotely control and monitor the system wherever they are, and they won't have to continually be present to water the plant. And I used a Blink app to help me monitor and see all the values from a user interface. And this is actually connected to the hardware through a Wi-Fi, because I'm using an ESP32, which is embedded with a Wi-Fi type of connection. So what I do, I plug.
What do you want to do? Okay, so plug in.
And when I plug, the system is still offline for now. And this is an LCD that helps me see and monitors everything from the plant when I'm around. But if I'm not around, what I do, I simply connect it to the Wi-Fi, and it tells me that my hydroponic system is now online, and gives me the state of the pump. Just like now, the pump is on because the humidity is below 60 as I set it. And if I blow to vent out humid and hot air, every time it will go above 60, the pump should automatically go off, and it also tells me here that the pump is off, as well as the light, they both off. And my LDR detects the light if it's in a dark light. If there is no enough light, obviously the pump should go on. Thanks to this light dependent resistor, and it also tells me here on my app, wherever I will be, that the state of the pump is on, just like there. And the temperature is 26, and the pump is now on. And if I release it, obviously it detects the light and it goes off and tells me that it's off. And that's basically it.
Right, what was your biggest challenge?
My biggest challenge was actually, first of all, interfacing the hardware with the software. And that was very tough for me. And also, when it came to the pump, this is my inside, this is the inside. When it came to the pump, because I had to power it with the 3.3 volts, so I had to use another power supply, because one power supply was actually creating disturbances on the screen, on the LCD. It was not showing proper values. It was showing something like Chinese, I don't know. So what I had to do, I had to look for another power supply to power it with a 3.3 volts, so that everything runs smoothly.
Okay,
Zet even met elkaar aandacht van dit er nou op te zetten, won't you? What is that?
It's a back boost, it's a DC regulator, adjustable regulator. It converts the 12 volts from the power supply to the required 5 volts to power up my
And this display here, what is that?
It's another back boost that helps me get the 3.3 volts for the pump.
So why did you hide the displays inside the cabinet?
Sorry?
Why did you hide these displays inside your cabinet?
Because it's not actually useful to everyone. Like, it's just for my system.
And fault finding, it's good.
Ja. Dat is also die moeder. Laat me het goed afvieren. Nou, die adres is daar.
Bel hulle.
Yes, of ek wou hom, hulle kry nou nie die plek. Hulle is by die plek. Het ek niet gedaan.
Okay. All right. The wiring is a bit suspect. I told you that. Okay, I think you could have really,
I did.
yeah, could have done it a little bit better. Yeah, okay. Well, good. Thank you.
In hydroponic systems, your nutrients, you switch the pump on and off, but isn't it that most hydroponic systems have got constant
Yes,
flow?
yes.
But you switch your pump on and off.
Yes, actually,
For dosing.
Huh?
Basically, what he's basically doing is for dosing purposes.
Oh, it's dosing,
So
it's not...
just simulating the
because
dosing part, yeah.
Okay, just the dosing part,
Yeah,
because
that was
the
with the-
flow is continuous.
Yes,
yes.
yeah.
But the dosing of nutrients.
That's basically what he demonstrated. Yeah.
But now the measurement is not on the nutrient content, the measurement is
On
on...
the pH.
Huh?
On the pH.
Is it,
Okay, but that
is it the
didn't
measurement
have
on
to
the
do.
pH? Okay.
Okay. All right. Thank you.
Okay, good day, good morning everyone. My name is Tumeleng Mwako. What I have here is a ESP temperature data logging using ESP to micro SD card. The problem that I've actually identified is in most companies, server rooms are very vital. So when you have high temperature, what happens is you can lose all your switches and routers in the server. They can actually start getting heat and get damaged. So yeah, I've designed a temperature data logging system which stores data onto a micro SD card. The technology that I've used here is I'm using an DHT11. It's a temperature and humidity sensor, but I'm only using temperature on it, not the humidity part. Yeah, I've
But you know that's
interfaced it.
important for a control room. Because if your humidity is too high, you're gonna get moisture on your contacts, and then you've got
And you've got the
Oxidation.
sensor, why didn't you use it?
yeah. So
Okay.
all right. Okay. I'm just saying it's very
Yeah,
important
yeah.
factor actually that you have to bring in. Okay. But it's fine. Okay. Continue.
Okay, yeah, I've interfaced it with the ESP32 and the micro SD card module where I'm connecting the micro SD card for storing data. Yes, the issues that I came across here was basically refreshing. I'm using an HTML. I'm viewing data on an HTML page. So the refresh, the automated refresh, that's what I had an issue with. And unfortunately, I could not get it right. Because every time I tried the code for that, it actually stopped reading the data. So yeah, what I have now is it measures temperature and it stores it onto the SD card for future review.
All right. Show us.
Okay, this device here connects to the Wi-Fi, local Wi-Fi. So I can use any device that is connected to the local network to view the data. And this is the IP address I'm using for connecting to the device. So now, after starting the device, it's now ready, it's storing data to the SD card. So I can connect using the PC. Then on the HTML page, what I'm looking at is the current temperature reading. So if I blow onto I'm using the air to blow into it. And if I refresh, I'm expecting
But why don't you put refresh
higher
inside the page?
temperature. Come again?
Because on HTML you can do auto refresh.
On the page itself,
Yeah.
is it?
It's just a simple HTML command.
Yeah.
Okay. Now,
Okay.
all right.
That's why it's reading high temperature.
And how fast do you sample? Or no, how many?
You sample
intervals
rate.
is- Yeah, you sample rate
Every
of
second.
every second. Okay.
So I can also use the code just Then it does work. Then yeah, now I'm gonna check if it stored the data onto the SD
No,
card.
you just forgot to put the SD card. This is a nice case, it looks,
Yeah, very nice.
this looks good.
Thank you.
But you will be able to open it for us, eh?
Yes.
And this one was vandaag.
So this is the
Yes,
time
good box.
release I have.
Yeah.
21/11, the 8th. This is the time. I think the time is a bit 1 hour. behind.
Okay, but that's what, yeah, that's fine. I want to see that. Okay, just open that quickly. See what is going to hit us.
Kijk hoe ver.
Okay, yeah. That's what we expect. Then can you just want to look inside? So this is typically what we expect in terms of wiring, neatness.
Neat layout box.
Okay, so this is typically what we expect. Okay,
Thank you.
good, thank you very much.